Okay, this mini lecture is going to introduce the idea of temperature, how we measure temperature, and then actually the 3 different scales that we use to measure temperature, which one we typically use scientifically, and how we convert between them. So temperature, of course, is a measure of how kind of hot something is, right? So hot or cold, whatever way you want to think about it, but it's the measure of how hot or cold something is. And various properties can change with temperature. So understanding kind of what temperature does is a little bit important, right? So we need to know how to measure temperature so that we can analyze and appreciate how various things change with temperature. So just as an example of that, when you're walking down the street, you know that there are kind of with concrete, there's little kind of line spaces between the sidewalk blocks as you're walking down the street. And that's because as the sidewalk heats up, it's going to do what's called thermal expansion. Check that little video out. And as the sidewalk cools down, it's going to do thermal contraction. And so there needs to be spaces for the sidewalk blocks to expand and then, subsequently contract. In our study of electricity, resistivity, the amount of resistance in a wire, in a conductive material, depends on the temperature. And so it's really important for us to get an appreciation for what temperature is. Now, we measure temperature using, of course, a thermometer. And we're not going to really talk about how thermometers are constructed, but essentially they rely on the principle of thermal expansion to measure the temperature. So when we talk about thermal expansion, you'll be able to see the connection to how a bulb and a liquid in a thermometer, how that liquid, if it is expanding at a rate different than what the glass is expanding that it's in, or the material that it's in, will expand up that tube, and the level of our liquid will rise in the tube, and how much it rises in that tube is going to be relative to the amount of temperature change. And so again, we'll look at that in more detail in our our thermal expansion video. And so one of the things that we're going to do in this little mini lecture is talk about temperature scales. So the different ways we describe temperature. And we have 3 different temperature scales that we use. One is the Fahrenheit scale, and this is primarily used here in the United States. The Celsius scale is used not in the United States, pretty much everywhere else. And then we have the Kelvin scale, and this is our scientific scale. So this is used exclusively almost in the sciences. It's our standard unit of temperature. When we talk about standards, this one is our standard for temp. All right. Now, to determine a scale for anything, we kind of look at 2 benchmark points. And the 2 benchmark points that are used for temperature are the boiling point of water and the freezing point of water. So these are values that are commonly known. You should know them. You should remember them. And they are going to relate and be what we can then use to relate our 3 scales. So I'm just going to put for degrees Fahrenheit, the boiling point of water in degrees Fahrenheit is 212 degrees Fahrenheit. The freezing point of water is 32 degrees Fahrenheit. For degrees Celsius, the boiling point of water is 100 degrees Celsius, and the freezing point of water is 0 degrees Celsius. And for our Kelvin scale, the boiling point of water is 300, and 73.15 K. And the freezing point of water is 273.15 Kelvin. Now, the Kelvin scale, our standard unit of temperature, has a 0 point that is important for us from our understanding of what it means, this Kelvin scale, this idea of thermal energy, this idea of where molecules are moving because of their thermal energy, that motion we have known to be called Brownian motion, that this ceases. So at 0 Kelvin, all motion stops. Okay, absolute zero, this is called. There is no oscillating of molecules in solids. There is no movement of molecules. There's no liquids at all, or gases for that matter. All molecule motion, atom motion ceases. Okay. Now, each temperature on the Celsius scale corresponds to a temperature on the Fahrenheit scale, which corresponds to a temperature on the Kelvin scale. And you might already be able to see some relationships that exist, but we can use these ratios and these relationships to get specific equations that allow us to go between Fahrenheit, Celsius, Kelvin, and Fahrenheit. So I'm going to share those with you. For the Fahrenheit temperature in degrees Celsius, so if I want my temperature in degrees Celsius and I have my temperature in degrees Fahrenheit, the conversion between Fahrenheit to Celsius is 5/9 the temperature in Fahrenheit minus 32. If I have my temperature in Celsius and I want my temperature in Fahrenheit, you could do the math, but I will also just provide this, is 9/5 times the temperature in Celsius plus 32. So not quite the same. In this case, it's just 9/5 times the temperature in Celsius plus 32. And if I want to go from the temperature in Fahrenheit to the temperature in Celsius, it's 5/9 times the quantity, temperature in Fahrenheit, minus 32. Those are the most difficult ones. If we look at Celsius and Kelvin, we see that those ratios are kind of the same. 0 is to 273.15. If I go 100 more degrees Celsius, I get 100 more steps in the Kelvin scale. So a single change in Celsius is the same as a single change in the Kelvin scale, right? So converting between Celsius and Kelvin is very straightforward. If I want my temperature in Kelvin, it's simply my temperature in degrees Celsius plus 373.15. So these are our conversions between our three temperature scales. All right, so let's do a quick little example, just kind of practice with this idea. Okay, and I will pop that up there and let you read that problem. So I work with a hockey player who lives in Canada. He is from the Canada world of hockey. And he was telling me in our meeting how excited he is about the upcoming weekend temperature. It's supposed to be 28 degrees Celsius in Canada. And then he quickly says, oh yeah, you don't use Celsius. So you probably don't even know how beautiful the weather is going to be. Well, what did I tell him? First of all, I'm a physics professor, so I know exactly what beautiful weather you are about to have. So our temperature in degrees Fahrenheit is equal to 9/5 times the temperature in degrees Celsius. So I'm going from Celsius to Fahrenheit plus 32. So my 9/5 times 28 plus 32, and we find a balmy 82 degrees Fahrenheit. So just using that relationship between Celsius and Fahrenheit. And if I wanted to really wow him with my sophistication of this standard unit of temperature, I might say that, well, if I want to go what it is in Kelvin, because after all, I'm American, but I'm also a scientist, then my temperature in degrees Celsius plus 273.15 gives me my temperature in Kelvin, and my temperature in Kelvin was 301.15 K. All right, so just getting used to some of those equations, being able to recognize if we're operating in Fahrenheit, Celsius, or Kelvin. We're going to find that some of the equations that we use, we're going to need to convert to Kelvin. Some we're going to stick with Celsius. We are not going to very often use in our analysis Fahrenheit, but I'm going to make sure that you know how to convert it. All right, good job.